Hello everyone, we are on Unit 6, Day 1. We are learning about proofs. So we're going to be talking about everything we've learned this semester and now proving it. So the first thing we're going to do is write some definitions down. So I'm going to take my time and talk about this. So Day 1 is just, again, that introduction. So let's talk about logic, okay? So logically, how can we prove something? So one way is by inductive, okay? Inductive reasoning. So uses specific examples to make a general rule, and it uses patterns. So on Monday, let's talk about the hybrid schedule. Okay, so the hybrid schedule, it went A, B, A, B. So if yesterday was B day, that would mean the next day was A day. We use the pattern to figure out what would happen next. Okay, what happens? So what is the rules? Compared to deductive, you take a general rule and uses it to make more specific examples. So you're taking from previous information to make a rule, okay? And then you create more examples from that. So we'll talk about the difference between inductive and deductive. Okay, and then the very last thing you want to write is a conjecture, a best guess based on known information. So based on what's happening, what can we make a rule from that? Okay, so let's make a conjecture. So you're going to complete your homework. So the conjecture is you're going to do well on the test, right? So you will be successful on the test because you are going to know how to practice it. Okay, so that's my conjecture. Yay! So that's based on a pattern that we've seen. Okay, missing school, we won't be successful. That can be a conjecture. Won't be successful on the test because you've missed the material. Want, want. So that can be good examples of a conjecture, okay? So inductive reasoning. Again, that pattern. So if I have A, B, what would be the next one? Okay? Compared to deductive reasoning, a good one I saw. Okay, a deductive reasoning is just making a rule. Okay. Oh, a square is a quadrilateral. And how do I know that? Well, because I know that four-sided shape, so from my previous examples or previous knowledge, a four-sided shape is called a quadrilateral. So making a general rule. Okay, so inductive, making a rule based on the patterns, and deductive is making a rule based on previous information. Okay, so we'll talk about that more at a different date about inductive and deductive. You can definitely look up examples of these. This definitely happens a lot in science class. So how are we going to use information and prove our point? Okay, so we're going to make a conjecture. So we're going to see what is the pattern. Okay, so what am I doing from one number to another? So 3 to 5 is plus 2. 5 to 9 is plus 4. 9 to 5 is plus 6. So what should be the pattern? So we're going 2, 4, 6. What do you think is going to happen in the next one? So 23 minus 15, well, by golly, that's 8. So what should I do to get to the next number for the pattern? So, okay, this would be inductive reasoning because I'm following a pattern. So I'm going to add plus 8. So that's going to be 33. And then I'm going to add 12. And I can keep going over and over and over again. So 33 plus 12, and I get 45. Okay? All right, so 3 plus 5 is 8. 5 plus 1 is 6. 11 plus 3 is 14. 7 plus 13 is 20. So what are we doing? So it looks like I'm going 3 to 5, okay? And then the next number over is 5, okay? So what on earth is happening with this pattern? Is there any logic to what is going on from one number to another? Okay, looks like we're just adding numbers together. Do you guys see any pattern on what they're trying to figure out? Are they all odd numbers? Am I adding, so 8, 3, and 5? No, I don't see any numbers. Let me know in class if you see any, if you can notice any patterns. It looks like I have, when I'm adding, looks like if I add two odd numbers together, I get an even number. You guys noticing that? So let's come up with another set of odd numbers. So let's pick 17 and 5. 17 and 5. So it looks like my conjecture means that my two odd numbers, if you add two odd numbers together, you should get an even number, which is accurate in every example I find. Okay? All right, let's look to see what we can figure out with this. So this looks like this is a 3-sided, a 4-sided, a 5-sided, and then we have 6, and then 1, 2, 3, 4, 5, 6, 7. So now my next one needs to be 8. So I need to make a stop sign, which is an octagon. 1, 2, 3, 4, 5, 6, 7, 8. So 8-sided. Okay? So caution, make sure the pattern works. Like it works all the way through. Okay? Okay? And if the pattern doesn't work, then you can just say you can't make a conjecture. Okay? So for all of these were all inductive reasoning questions, and you just needed to finish out the pattern. All right, what is a counterexample? Proving a conjecture is false. Okay? So, for example, a student missed school, but they rocked the test. Woohoo! So that could be that's proving my conjecture is false. A counterexample. They missed class, but they watched these videos. What? They watched these videos that we are making and we're working so hard on, and they still rocked that test. All right, so we are really trying our best to help you guys out. You guys just come to class or watch these videos, and let's do it. We're almost there. So when you add a positive number and a negative number, the answer is negative. Okay? So when you add a positive and a negative, the answer is negative. Well, I'm going to come up with a counterexample of when this doesn't work. Okay, a negative number. Let's say the negative number is -3, and the positive number is 10. Well, that answer is 7, and that is not a negative number. Okay, so a counterexample is proving your conjecture wrong. So proving like, hey, I missed class, but I'm trying my best, and I'm watching the videos, and you rocked it. That is a counterexample. Okay, get it done. You guys got this. All bears are brown or black. Well, I found a picture of a polar bear. Well, a polar bear isn't brown or black, and it's a bear. Okay, so that is an example, a counterexample. The last one is all jokes are hilariously funny. Well, I don't think all of you would think that this is hilariously funny. Can monsters be good at mathematics? Only if you're Count Dracula. Ha ha. Maybe it's funny, but is it hilariously funny? Is it like you're crying because you're laughing so hard? Meh. That might be a counterexample. All right, so let's actually get to the nitty-gritty. So you guys have been solving problems for at least 5 years now. So these are ones that you've seen. So if I have x plus 10 equals 50, which one is it? Well, what would I do to both sides? I would have to subtract the 10 to both sides. So that would be called a subtraction property. Okay, so subtracting means I'm going to be subtracting something to both sides. So I'm going to subtract this a to both sides. Okay, now let's do another example. What if I had 3m equals 33? What do I do to both sides to isolate the m? Well, I'm going to divide something to both sides. So if I have ax equals c, I'm going to divide a to both sides. That's the division property of equality. All right, let's try another one. So it's what is the operation in order to isolate the variable? All right, multiplication. So what if I had t over 4 equals 13? Well, what am I going to do to that 4? Well, I got to times the 4 to both sides. So if I have x over a equals c, I would use different colors. I'm going to times a to both sides. So you'll get rid of the a on this side, and you'll times the a on the other. All right, the very last one. If I have x minus a equals c, what am I going to do to both sides? Well, I'm going to add a to both sides. Okay, so it's the opposite operation. What do you do to get rid of something? Okay, so subtraction, I can show that I have x plus a equals c. So what do I do to both sides? Well, I'm going to subtract the a to both sides. Okay, so the operation to isolate the variable. Distributive property. So if I have a times b plus c, I'm going to multiply the outside number to the inside terms. So ab plus ac would be how I do distributive property. Simplifying like terms. So if I had a x plus c plus b, oops, let me do a different color. Just want to make this as clear as possible. X, I'm going to combine the ax and the bx. Okay, because that's like terms, and then I'm just going to bring down the c. I'm going to add the ax and the bx together. So we can make that dx when you add them. All right, given, what information did they give you to solve? So what do teachers give you to be successful? Okay, in geometry, we give you notes. All right, prove. What are you proving? The outcome. What do you want the answer to be? So what do you want your grade to be? So given, so we're going to write this down as my 10y plus 5 equals 25. So the first thing you do is write down the given. Okay, now I need to solve it. Well, what's the opposite of adding 5? Well, that is subtracting 5. So I'm going to write subtraction property of equality. And you can, of course, abbreviate because that is long-winded. And what's the opposite of multiplying? Well, that would be dividing. So then I'd write division property of equality. There we go. So I have my problem, I solved it, and I got my proof. So you know you're done when you prove in what they want you to solve for. So we're taking multi-step equations and solving them and using them to make proofs. Okay, let's try the next one. So first I'm going to write it down into my chart, and I'm going to look to see what's my first step. Should I multiply 2 or add 1? I'm first going to add 1. So 1/2 p equals 12. So that is the addition property. And then what is the opposite of 1/2? Well, that's going to be timesing, multiplying by 2. Okay, so multiplication property. So what are the two steps to go from given to prove? That's what we're trying to figure out. Okay, so how are you solving this? And then what are your reasons? Okay, your reasons are distributive property, math fact, or symmetric, and then these 4. Okay? All right. So here's another one. 3m minus 11 equals 16. I want you guys to try this one. So how are you going to get to m equals 9? Okay? How are you going to get to that? What are the steps you're going to take? All right, the next one. So 6w plus 7 equals 8w minus 5. I'm going to write that that's my given. What do we want to do first? Let's come up with a game plan. Do we want to move the 7 or the 5? I'm going to move the 7 to the right. So it's addition. I'm going to make it subtraction. So I'm going to do the subtraction property. And I'm going to have 6w equals 8w minus 5, so that's negative 12. Okay? And then from here, what do you guys want to do? So I need to get the w's together. So if it's 8w, I'm going to move this over this way. So that's subtraction property also. Okay, so lots of writing for this unit. So subtract 8, and that's negative 2w equals negative 12. Okay, all right, what's my last step? Well, how is negative 2 attached? Well, it's divided. Okay, it's multiplying. So what's the opposite of multiplying? Dividing. So I'm going to use the division property. I'm going to get w equals 6. So I have 1, 2, 3, 4 statements, and I have 4 reasons. 1, 2, 3, 4. Okay? So hopefully the color coding helped. I know it got a little tricky on here. So the green, then to the blue. All right. We're just moving right along. Negative 5x plus 2 equals 3x plus 6. So I want you guys to try this one out and check back. Oopsie. All right. So first we had the given. I subtracted the 2. I subtracted the 3x. I divided negative 8. And then the last one is a math fact. So going from negative 4/8 to negative 1/2, you can write math fact because you simplified. Okay, so simplifying fractions, you can write down math fact. All right, so thank you so much for joining me on day 1. Let me know if you guys have any questions. My name is Ms. Robinson, or again, you can talk to your amazing teachers out there, and have a great day. Bye, Huskies.